All right, so this is Algebra 2, Lesson 9.1, and getting started with a chapter involving rational expressions. And when you see that word rational expressions, hopefully your mind says fractions, right? So that's what we're going to deal with, basically polynomial fractions. All right, so Lesson 9.1 is simplifying. Simplifying is really a review lesson. Going to go through quite quickly a couple nuances, and should be an easy lesson for you, but it is foundational, so please focus in, pay attention, ask questions in class tomorrow if you're not sure of some of the things that I've mentioned. All right, so how do you simplify? We're going to factor the numerator and the denominator. So back to factoring, and factoring is a key concept at the end of Algebra 1 and throughout the rest of your math career. So we're going to have to factor the numerator and denominator, and then you're simply going to divide out common factors. Right? Divide out common factors. Pretty simplistic, not a whole lot there. However, we do have to keep this in mind. Since division by 0 is undefined, so, and again, in the way I like to look at it, though many say undefined, it's really infinity, right? If you had an x divided by 0, then that's infinity. There's an infinite amount of nothing and everything. It's infinity. In other people's minds, it's undefined. And so we can't have that. You can't have a 0 denominator. It doesn't work. My calculus professor in college said it blows things up. All right, so however you want to look at it, you can't have it. So you can't have division by 0. So since division by 0 is undefined, variables in the denominator result in possible values of the variable that are not usable. And we're going to call these excluded values. Excluded values. I mean, same concept as extraneous roots and such. Values that don't work. Values that aren't part of the domain, in this case, values that result in a 0 denominator. And if you got 0 in your denominator, then you're going to have excluded values. So a couple examples. So this first one here, we have a 12 divided by a 7xy. I could care less about the 7. I don't care about the 12. If there was a variable in the top, I wouldn't care about it either, and I'll mention that in a minute. What I am concerned about is that x in the denominator and that y in the denominator. So here's the reality. If in the denominator the x were a 0, and I'm right over here, right? If the x were a 0, then the denominator would be 0, and that won't work. So x cannot be 0. 0 is an excluded value. And when you look at y, if y were 0, that would make the denominator 0. So y cannot be 0. There are two excluded values in this problem. X cannot be 0, y cannot be 0. Why, you ask? Because again, it would make the denominator 0, and when the denominator is 0, you get infinity or undefined. Second example. Now you might look at this and say, hey, look at that. You got an n on the top. Oh, Windows 7 keeps doing this to me. You have an n on the top and you have an n on the bottom. Let's just get rid of the n's. And by the way, we're going to do that later on. However, even though we can divide out the common n's, that doesn't negate the fact that the n cannot be a 0. N cannot be 0. Now, what about the z? What about z? Now, if you're quick to say, well, z can't be 0. Well, au contraire. All right, let's take a look. So what happens if the z is a 0? If you do the parentheses, you get 3. Well, that's not a problem. Right? So this goes back to the concepts that we learned with quadratics, and we already know these concepts. And so what value will make the parentheses a 0? Because that's the factor, right? The whole parentheses is a number. What value would make the parentheses, the quantity, that binomial, 0? And again, the way you figure it out mathematically, if you can't do it in your head, is to set the factor equal to 0 and solve it. Move the 3 to the other side, divide by 2, and in this case, we're figuring out what z cannot be. So z cannot be negative 3/2. So n cannot be 0, and z cannot be negative 3/2. Any value of a variable that will make the denominator 0 is not allowed. It's excluded. It's not usable. Okay? Same concepts as solving quadratics if you can't see that clearly in your head. All right, so let's do a quick review of factoring here. So don't forget that Windows 7, you're going to drive me crazy. Don't forget that in any factoring, your first thought should always be to factor out common factors first. So factor out common factors first. Factor out common factors first. You always have to be looking for those common factors, right? So let's take a look at the example here. If you look at an 8, just look at the coefficients first, the multipliers, the 8, the 6, and the 12. There is a common 2 out of those, leaving a 4 as the front term, a negative 3 as the middle term, and a positive 6 as the back term, right? We took out the common 2. Now, when you look at the variables, there's also a common n. So we can get an n out of every term, leaving you an n cubed in the front term, an n in the middle term, and no n's in the back term. So we have 2n times the quantity 4n cubed minus 3n plus 6. Again, this is all review. I don't want to take a lot of time here. We've done this. We've been factoring all along. But, you know, the whole idea of simplifying rational expressions is factoring. And so it's factor, 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 factor. So be careful there and make sure that we can still do that. All right, further refresh your memory. Never, ever, 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 ever forget about the difference of two squares. Windows 7. Don't forget the difference of two squares. And so if you look at this, you say, oh, difference two squares. Well, also don't forget factor out common factors first. Oh, Windows 7 is really at it today. All right, let's factor out the common 4, right? We got a common 4? No, common 5. So I can get a 5 out of both of these terms. That leaves a 4 coefficient in the front, negative 9 coefficient in the back. And again, we have y squared and z squared. Okay, now we have a difference of two squares. Don't forget the factor you factored out. All right, how do you factor a difference of two squares? 2 parentheses, remember? Plus in the middle of one, minus in the middle of the other. Square root of the first goes first. What's the square root of 4? 2. What's the square root of y squared? Y. So 2y goes in the front. Square root of the back term, I'm not worried about the negative sign. Putting the plus in one, minus in the other takes care of that, right? Square root of 9z squared is a 3z. And we end up with 5 times quantity 2y plus 3z times quantity 2y minus 3z. Okay? Just simply difference of two squares. And then, of course, don't neglect or forget the aspect of factoring by trial and error. Hopefully, we're much better at this by now. We've been factoring all year. But again, don't forget, factor out common factors first, and I see a common 3. So that leaves you 2a squared plus an a minus 6. Now I'm going to look to factor the trinomial and the two binomials. Remember, the fronts have to multiply to the front. So, hey, 2a and a, that's the only possibility there in this situation. Good. Be careful, a 2a, it matters where we put the back terms. Okay, so remember, when I'm dealing with a negative 6, I have to keep my focus on the middle term. The middle term has to be a 1a, right? A positive 1a. And remember, the middle term is a product of the outer terms times the inner terms, right? So that's what I'm thinking of the whole time. So here, I'll show you. Don't write this, but, you know, this would be my thinking. If I put a negative 3 here, the outers are a negative 6a. The inners would then be a positive 2a. That's not going to get me to a. These are the thoughts that I'm going through before I ever even put anything down. So again, in my thought process, I always look at this back one first because I'm always multiplying the outers. Okay? It's always my first multiplication. So I'm thinking 6, I have 1 and 6, I have 2 and 3. Okay, so I'm thinking if I go 2 here, that's a 4. That would give me a 3. A 4 and a 3 can get me a 1, and I need it to be a positive 1, so I need a positive 4 and a negative 3. And again, I used two values, negative 3 times 2, that gives me that negative 6. So again, remember your outers, positive 4a, plus your inners, a negative 3a, has to equal that middle, positive 1a. And it does, and that's the factoring of that. All right, all of this just to review our situation and get us ready to go ahead and reduce. Okay, simplify, it says, and state all excluded values. So you can state the excluded values ahead of time. We'll do them at the end. But, you know, this is just a simple problem of reducing. Numbers with numbers, variables with variables. We have a monomial over a monomial. All right, so I'm looking at this. 32. All right, 32. Negative 8 times 4 is 32. 28, 4 times 7. And we can divide out the 4s, right? Okay. So look, in my answer, I'm going to have a negative 8 on the top and a 7 on the bottom, right? Looking at my x's, I have 5 of them in the top and 3 in the bottom. The 3 in the bottom wipe out 3 of the ones in the top, leaving me 2 left, right? X squared. And look, if you can't do that, change the x to the 5th to an x squared times x cubed and divide out the common x cubes. But again, 2 left, and I hope you can do that. Looking at my y's, I have 1 in the top and 4 in the bottom. That 1 in the top wipes out 1 of the 4 in the bottom, leaving me 3 in the bottom. And there's the solution, negative 8 x squared over 7y cubed. But remember, we have to state excluded values. And x cannot be 0 because that will give a 0 denominator. And y cannot be 0 because that will give a 0 denominator. So all of that is the solution to A. Looking at B, do not do this. Cross out those 3's. You can't do that. Students always want to do that. You can't do that. Okay? The reason you can't is the 3x squared is tied into this negative 15x. They are one thing. It's a binomial. We don't use a parentheses, but it's one thing. The fraction bar is the grouping symbol, so we don't need that parentheses. But you have to understand that. Now look, if you ever forget, could you just make up a simple example? Look, how about something like this? How about 3 minus 5 over 6? Okay, 3 minus 5 is a negative 2. Negative 2 over 6 is a negative 1/3, right? We know the value because it's numbers. Does this give you the same value? No, it gives you a negative 5/2 or actually a negative 4/2 or a negative 2. So no, it doesn't work. You can just do simple numbers. But don't make that mistake. You cannot do that. You cannot do that. It'll kill you. It'll kill you this chapter if you do something like that. Okay, what we can do and what we should do is factor. All right, I'm going to factor out common factors first. There's a common 3 in the top. And there's also a common x in the top. All right, when I take out the common 3 and the common x, that's going to leave me an x in the top and then a minus 5. Right? That's the factoring of the top. Again, you can always multiply it back out, make sure you get back to the original, and we do. Right, the bottom's already pretty much factored, so here's now. Now look at the difference. This is, you got a 3 times an x times an x minus 5. We have 3 possible things we can reduce. The 3, the x, and the whole x minus 5. Okay? So there's three things possible that can be reduced up top. Now the bottom is a 2 times a 3. If I were to write it out, we wouldn't do this normally. X times X times X, right? There's your 6X cubed. So 1, 2, 3, 4, 5 possibilities of reducing at the bottom. But clearly, this top 3 divided by a bottom 3, that's a 1. This top X divided by one of the bottom X's, that's a 1. And that's it. It's all we can do. Again, you cannot cross out one of these X's with that X. You cannot do that. Again, the concept is this is one quantity. You have to take it as a whole or nothing. Whole parentheses is one quantity. So this is all we can do. So what do we end up with on the top? An X minus 5. What is our bottom? A 2X squared. And remember, it did ask for excluded values. So in this case, there's only an X in the bottom, and if the X were a 0, then that would give us a 0 denominator, so X cannot be a 0. All right? That's what we're doing. That's the situation. A lot of factoring. All right? So if you take a look at the next example here, go a little higher here, give me room above. So when you have to do homework problems, I would always leave space above your next problem. As you write it, leave some space above so you can factor the numerator, right? And that's what you got to do. So, you know, if you want to do these yourself, just pause the video and then go ahead and do them and turn it back on and see if you got it right. So this top one, you're looking at it and say, oh, difference 2 squares. Yeah, plus in the middle 1, minus in the middle of the other, square root of the first, square root of the last, right? There's the top. Bottom, factor out common factors first. Let's get out a common 5. Leaves you an X minus 2. And now I can take this whole X minus 2 quantity and divide it by this whole X minus 2 quantity. They divide out, and that's it. No other reducing. I end up with an X plus 2 on the top and a 5 on the bottom. And remember, excluded value. All right, be careful now. Be careful now. So I can either get the excluded value off of the original, or I can get it off of the factored form. The factored form is easier. According to this, X cannot equal a 2. Because if X were 2, then that parentheses would be a 0. You'd have 5 times 0 is 0. Again, how do I get that? I did it in my head, but you can do X minus 2 equals 0, solve the little equation. So there's the answer to that one. All right, again, pause if you want to. Got a lot of factoring here. I see a common 3. I see a common A. It's going to leave me a 2A squared minus 3A minus 9. And look, quite honestly, and by the way, I always cross out what I factored. What about this trinomial? Does it factor into 2 binomials, 2A and A? I have 3 and 3, or 1 and 9. So 6. Look, if I put a 3 there and it's negative, I'll get a negative 6A with a positive 3A in the middle to give me that negative 3A of what I want, right? The outers is a negative 6A, the inners a positive 3A, and it does add up to the proper middle. That is the factoring of that. Okay, a lot of factoring. Denominator, looking for common factors. Oh, there's a common A squared in the denominator. 2A squared plus 11A plus 12. All right, let's try to factor this trinomial. 2A and an A. I guess I'm stuck on 2 A's in the fronts for some reason. All right, 12. 1 and 12, 6 and 2, 3 and 4 are my possibilities. I got to add up to an 11. Oh, look at this. If I put a 4 there, the outers are an 8A, right? And therefore, then when I put the 3 in the middle, that gives me the other 3 for 11. So that's it. 4 there, 3 there. So again, watch. My outers are an 8A plus a 3A for the 11A, right? So that's the factorization of that. So cross that out, right? I factored those. All right, so I'm working with the very top and the very bottom. Let's do my A's first. 1A on the top wipes out one of the A squareds in the bottom, leaving me an A on the bottom. Be careful now. Don't lose that A. this whole 2a plus 3 can be divided by this whole 2a plus 3. And that's it. All right, I'm going to write my answer here in black so it stands out. I have left in the top a 3 times the quantity a minus 3. Now, normally you would multiply that out and get a 3a minus 9. For time's sake, on these type of problems, we usually leave them factored. But that really is a 3a minus 9. Bottom, a plus 4. And don't forget your restricted values. According to this parentheses, if you were set it equal to 0, you would get a cannot equal a negative 3/2. And according to this parentheses, you would get a cannot equal a negative 4. So there's the answer, 3a minus 9 divided by a plus 4, where a cannot be negative 3/2 and a cannot be a negative 4. That's the idea. Got a couple more left here as you're just practicing factoring. Again, pause the video if you want, but I'm going to go a little quickly here. The top one, again, I'm going to try to factor. N and N, I got a negative 10, positive 3. That's easy. 5 and 2 will give me a 3 difference. I need the 5 to be positive and the 2 to be negative to give me a positive 3 in the middle. Okay, so that's the factoring that. Do you remember how to do a cube? The difference of 2 cubes. All right, don't forget this 8 is like a 2 cubed, right? Do you remember the pattern? Binomial, trinomial. Remember what the sign is in the binomial? Matches. Remember what the first sign in the trinomial is? Opposite. And the back sign in the trinomials are always positive, regardless of what the middle sign is in the original. Okay, do you remember how we do them? Cube root of the front goes in the front, right? Let me get rid of that circle. Cube root of the front goes in the front. In the front here is the cube root squared, so the n squared. What goes in the, all right, we'll leave it at that. What goes in the back? In the back goes the cube root of the back. What's the cube root of 2 cubed? That's a 2. And again, all the way in the back, the cube root of the back squared, 2 squared. And then what is the middle term? The cube root of the front times the cube root of the back. So I'll clean this up, and I would have done it cleaned up in the beginning, but I want to just do it as we learned it, right? It's in n minus 2 times quantity n squared plus 2n plus 4. Okay, can we reduce? Yes. The n minus 2 and the n minus 2, and that's it. That's all you're going to reduce on this one. We're left with an n plus 5 in the top, and n squared plus 2n plus 4 in the bottom. Don't forget excluded values. From this front parentheses, n cannot be a 2. Oh no. What are we going to do with the back parentheses? Oh, mamma mia. Does it factor? No. It's quadratic, right? All right, don't bum out. We know how to do quadratics. Does it factor? No. We can't solve it by taking the square root of both sides. We can't solve it by factoring. We've got to use the quadratic equation. Now, it's been on most of your tests up until this last one, so hopefully you still remember it. X equals negative b, negative 2, plus or minus the square root of b squared. 2 squared is a 4, minus 4 times a, so 4 times negative 4 times 1, right? The a is a 1, is a negative 4 times c. Positive 4 is a negative 16. All over 2a, which is a 2. Oh, imaginary. We don't have to list imaginary excluded values. So, I mean, but that'd be what it was. And, oh, by the way, this would be n, right? And this cannot equal. Right? So if you wanted to finish it out, you could, but it's an imaginary number, and so we usually don't worry about excluded imaginary numbers. Final answer. N plus 5 over n squared plus 2n plus 4. All right, the last one, just one little trick here. just to make you aware of. Look how similar they look. Again, do not cross out the 3's, do not cross out the x's. This is a quantity, though we don't show the parentheses. This is a quantity, though we don't show the parentheses, all right? They expect you to know that they're a quantity. Okay, so what am I going to do here? If you look at the bottom, I can factor out a -1 out of the bottom. Now let me just take it one step at a time so it's clear. If I factor a -1 out of +3, it leaves it as a -3. If I factor out a -1 out of a -x, it just changes the sign to a +x. Factoring out a -1 changed the sign of the front and the sign of the back. If you don't believe me, multiply it back out. What's -1 times -3? +3. What's -1 times x? -x. See how you get right back? So again, whenever you factor out a -1, you just change the sign of every term. Okay. Now, so that has become that. Now, let's use the commutative property and swap the order. Just for clarity's sake, do you see now how this whole x minus 3 can be divided by that x minus 3? And what do we end up with? 1 divided by -1, which is a -1. And oh yeah, don't forget the excluded values. X cannot equal 3. So the answer is -1, where x cannot equal 3. All right, listen, simplifying. It's all about factoring. Factor the numerator, factor the denominator, divide out common factors, and oh yeah, be careful about excluded values. Values of the variable that give you a 0 in the denominator and therefore are undefined, or which cause infinity. All right, hope you have a great night, and we'll work on this homework in class on Monday. All right.